Hi everyone, this is how to detail a staircase. In the previous tutorial we did the first half of the staircase. So in this tutorial we are going to do the second half of the staircase. So and as we did in the previous one, we copied this one downward, so we are going to copy this one also. So we copy it to one side, so we detail it separately. So and let me fine tune this so that it will be okay very well. So this is it. So we are going to detail this. So knowing this before we start the tutorial, this is the landing, the first landing, and the up here is the slab. You know, this staircase will connect to the this half will connect to the slab. So as we did, if you have not forgotten, we said in the part 1 that the main reinforcement is Y12 150 mm center to center, while the distribution is Y10 at 200 center to center, and the cover is 30 mm. So we are going to start. So we are going to leave a spacing of we calculate the spacing to be 36. Then, if you have not forgotten, where we said the reinforcement is Y12 and half of it is 6, so plus cover which is 30, so it gave us 36 then. So and this is 36, so we are going to copy this and leave a space of 36. You know, my style is I always first finish with the bottom reinforcement before I move to top. So let's finish with the bottom reinforcement first. So offset 36, so 36 like that. So bottom here 36. So I'm going to extend this one. So but I will leave a spacing of 36. So and when you are going, when you are going from the landing to the second half of the staircase, the reinforcement will not going to be like this. This one is like a scissor. So at the bottom here it won't form a scissor. The bottom here will connect directly to the bottom of the flight here. Get me right? When you are coming from the half landing, so the bottom reinforcement here will connect directly to the bottom of the stair. I say bottom of the half landing to the bottom of the stair. So I'm going to connect this one, trim it. So and I have left the spacing of 36 here. So the up here, so it will now going to connect to the top of the slab. So it's going to connect to some. When we draw the top of the slab, we will do that. And also the bottom here, the over here, it will be the same as the one we did here. So the same thing, but only this one that is different. So all you have to do is extend this, extend it. So when we draw the top, we connect it together. So now let's draw the top. So we leave a spacing of, as usual, spacing of 36. So let me copy this and move it this way, so to be able to put the spacing of 36 and remove this. So this is it. So this is the top of that reinforcement, and you know that the top that is coming here, let me leave a spacing of 36 from here to spacing of 36. So the top here we come here and have an anchorage length. So let me extend it. Let me even extend this. extend this. So this top here we have an anchorage length. This is the reinforcement top bar for the landing, so it will have an anchorage length. But the top coming here also, the top coming here, let me first do it for the landing anyway. Let's give the anchorage length of 1 meter. Anchorage length of 1 meter. 1 meter. 1 meter is not much. Let me make it 900 or 800 rather. 800, anchorage length of 800. So anchorage length for the top bar, you get that one right. So and I will join. So but before I go, I will write, this thing is not aligned. It's not aligned. I don't like it. Let me disjoint. I don't like it. Let me do some. Let me use a trick. So now we just smoke this. So I think it's aligned that way. So I will just have to click it and join in with the top of the landing. Join. But before I leave it, I will have to use a kink to show that there is a reinforcement there. So this is the top coming from the landing, and also the top on the flight. This is the top of the flight. Usually the top of the flight will not span through. It always stop at maybe 1/3 of the length of the reinforcement, but I don't usually use the length. I count 1, 2, 3, 4, 5. Maybe like 5 still. 1, 2, 3, 4, 5. Let me count 5. So just a reference line where it will stop. So this is the top for the flight. Top for the flight is different from the top of the landing. Top of the landing have its own anchorage length. This is it. But top for the flight we also have the anchorage length. So I specify 800 for this. Let me also specify 800 for this. Some people use 1 meter. Some people even use the half of the length of this landing. So it's an engineering judgment anyway. So let me use the half here. So to do the let me use kink to specify that there is a 2 reinforcement there. One is here. So here is it, here is it, here is it, and I will join it together. So this is it. You get on to right. So fine, let's delete this. So we are almost done. So now coming to the top here, to the top, this is the slab. The reinforcement here, this is the reinforcement coming from the slab. So it will come down. Let me do something. Let me extend this. So let me extend this. So the reinforcement coming from the top, from the bottom. The reinforcement coming from the bottom, we have the anchorage length also, and it stop. Usually we use 800, right? So it stop at 800 mm. I don't know the trick I can use here to draw 800 downward, but it's simple. Let me do it this way. So 800. Snap it and I will write 800. So this is the anchorage length. So for the bottom coming, so this is the anchorage length. So now all I have to do is just draw kink. So draw kink. So this one, and this one. So now we join it together. I don't need to provide the this thing, the spacing here, because this thing continues like that. So and also for the top reinforcement of the slab, 36 downward. So the top we come here, the top will come here. If I use up that thing, let me trim it. So let me use the one I saw. So the top will come here directly, and we come to the top again. So get that one right. See the top coming from the slab here for the second landing. We come to the top here. So and it will stop at like 5 risers. 1 2 3 4 5. Let me use 1 2 3 4 5. Let me use this as a reference line and on my orthogonal to make it straight. So now this top will stop at this 5 riser. So I'll trim it. So this is it, this top. So this one and this one. So and I will join it together. Remember, so the bottom bar we did not provided the anchorage line for the bottom we just first view. So this is the bottom here, come here, and it will have its own anchorage length. So let me draw the anchorage length anyway. So the anchorage length will start from here. So we use 800, right? 800 for the anchorage length. So this is it, and I will draw kink. So let me draw the kink. So normally the kink I usually even specify the space. Maybe the kink is 40. I don't know, like, let me just draw it. So and I will drop it. I will connect it to the one here. I will also connect with the bottom here. You know, the bottom spans from here, and goes on to the 80. It reaches the up here, and we have this one anchorage length. So now we join it together. But this thing I don't need it here. So this is actually, oh my god, it's not joined. The reason why we are joining it is because of distribution bar. You know, we use the path array in the part 1. So to make it workable for the path array to work, we specify we join it together. So to create a path. So this is it. It has joined now. So now we can now provide the distribution bar. So distribution bar, we are good with this. So we are good. So we can now provide the distribution bar. So as we did on the part 1. So go to draw and pick donut. So the inside diameter of that donut is 0. So the outside diameter is 30. And you come here, specify it. So the first one we are going to draw is the bottom bar. So specify. So since this thing is 30 diameter, so we can specify 15, so that it will stay at the middle. No, I don't want that. No, it's not aligned. I don't like it. So donut. Inside diameter 30, outside 30, inside 0, outside 30. So 15. So I want it to stay on that thing. I think it's okay. So we select do not, and we choose the path array. We use path array anyway. So path array. So and we come to this thing. I think this software, the AutoCAD is not responding, so give it a minute. So we selected the path array. Let me select again path array and the path. So I think it's okay. So now select it and change the distance. I know the distance is 200 mm. So 200 mm and this place. So this is it. So all we have to do is delete the top here, we don't need it. So this is it. So similarly for the top reinforcement here, so top for the landing, so we provide the donut for it. Inside diameter 0, outside 30. So and we draw it downward. So we use the path array. So we click on the paths. So and we change the distance, which is 200 mm. So this is it. So that's it. But all you have to do is delete the one below. I even need to stress this one a little bit. So it doesn't need. Just let me delete this. So let me delete this. That's all. So we are done with the top and bottom here. So the top for the distribution for the top of the flight, top reinforcement of the flight. So I will draw the donuts, enter 0, 30. So we draw it to make it align. So we click it and we select the path array. You click the path. So then we change the spacing, which is 200 mm, then enter. You can't use spacebar, you use enter. So and then use this, then delete the one below, so we don't need it. So also for this, let's start from here, shall we? Let's start from here. I think the top here coming here, it will nick with this. Does it? It doesn't nick. Let me use my trick, the polyline. So I'll use the polyline to nick it together. So I think it's a nick. It's not aligned. I don't like it that way. I like it to be aligned. So the polyline once again. I see maybe that is the reason why it's not joined in the first place. Join. Then I think it's okay. So this is it. So I can now draw my donut, 0 at center, 30 at the edge. So we draw it and we make it 30, the 15. So select the object, click the path array, select the path. So and then it's good. So all we have to do is just change the distance to 200. I double click on the object anyway to change to see the property. And if you are using the higher version of the AutoCAD, the thing you can easily find it somewhere around here. So all you have to do is just change the item distance, or you click it and right click it. You can change it anyhow you want, depends how you are proficient in using the AutoCAD anyway. So now the bottom for this, I think the bottom for this has the anchorage length. The anchorage length is not joined together. Let me join it. It's not joined, so no cause for alarm. Let me use this. I think I didn't select it properly. Let me undo and choose the polyline again. Let me select it from here. I actually want it to connect so that the path array will work for it. That is my mission. So I think it's okay like this. It's joined. So I can use the path array. So I can use the path array to choose to not 0 inside diameter, 30 for outside. So and now let me start from here. Oh no, I don't like it. Let me move it properly. I think this snap is confusing. Let me off it. and that's good. Now select the object, come to part array, then select the part. So good. All I have to do is change the property and make it 200 mm, then enter. So now I will delete the top ones. So on the next thing in line is to annotate. We are done with this. So the next thing in line is to annotate, annotation. So we copy the annotation here. Of course, we have done that in part 1, so we don't need the repetition to save seconds. So all I have to do is change it. I copy this, copy. So I won't waste time in doing this anyway. You've got the point, and you know how to detail, how to annotate from part 1, so you can use the idea to do the annotation for this to save time. So let me just do this. So copy it and come to y20 at 200, that's distribution. Y20 at 200, that's distribution. I don't like it the way it is like this, so I will draw this and I will move this. So I even extend this line so that the thing will be aligned. It's good to make the work align. So that's it. And this one which is a main reinforcement. So I just need to remind us that the annotation we do for both main reinforcement and the distribution, for flight, for landing, and for the slab upward. So one more thing, the number of the reinforcement we are going to provide. So for this flight, so the spacing, the space of the span of that, the width of the flight is actually 1 meter. So we got that one from here. So let me show you the 3D so that you can see very well. So I made the distance from here to here, the reinforcement will span like this. Let me just help with this. The reinforcement will span like this. Let me put it at the module. So with the span like this, 1, 2, 3, like this. Let me copy and make it more practical. So let me off this. So the reinforcement will span like this. It will span like this, like this, like this, like this. So the number of reinforcement we are going to use throughout that length is what I'm trying to do. And from here, from this point to this point is 1 meter. You get that one right now. And we are using the spacing this side, spacing of 30, and this side spacing of 30. So 30 plus 30, that's 60. So now remove that spacing from this length. Let me use calculator. The spacing is 30 minus 60, which is 60. So 940. So now this 940, we are going to divide it by the spacing of the distribution bar, of the main reinforcement. So calculator, where is it? So divide it by 150, which is a 6 reinforcement bar, 6 river. So this is, instead of writing, it's 6.26 something, it's 6.26 something. So we are not going to write that 6. It's good to have more reinforcement that have less reinforcement in the site. So I made it 7, and I wrote 7. So that's good. This comes to the end of the tutorial for the second half of the stairs reinforcement. So in the next tutorial we are going to try using calculate how to calculate how I got this thing. I just gave you the value. So how I got this value, the main reinforcement y12 at 151 center to center distribution, but how I manually calculated it, and it's very short way. So when you are doing your modeling in any software and you want to quickly add your staircase load to the beam, so you can quickly calculate it manually. So and you will get the value and you distribute the load. Later on you will detail your staircase, the one I did. So thanks so much for watching our tutorial. So now we like you to subscribe to my channel, so it will keep me growing. And thanks so much once again.